Hello class, glad you can join me with today's Solving Polynomial Inequalities. So first thing, we're going to end up starting with one question, where we have to solve for x with this given inequality. So try to take a moment to do this and see what you can get. Alright, so what I like to do with these inequalities is, first off, I don't like dealing with a negative x squared. It just bothers me. So I'm going to actually divide by negative to both sides, and if you do that, right, you're going to get x squared plus 6x minus 7, but you have to remind yourself what happens when you divide by a negative. This here, this inequality, or sorry, this less than, greater than symbol in this case, is going to become a less than, so it has to be negated for 0. So when that happens, you must do that. So let's keep going. What we want to do is factor this out because we want to know where this is true. And basically make it as simple as we can to deal with this condition here of 0. So if we do this out, we're going to factor this, say x and x, both less than 0, is going to be factors of what creates 7 here. Well, we're going to have 1 and 7. The greater number is going to be positive, and negative 1 here. You can test this out and verify that this is truly this, but the nice thing to think about with this relationship here is, yeah, I can still solve it further and say x is going to be less than 1, or x is going to be, in this case, less than negative 7. You can say that that's great, but what we have to figure out is where this exists. Where does this exist for this inequality? AKA, what I like about using 0 is you can simply say, when is this here, this inequality, positive? Or in this case, when is this polynomial function negative, because it's less than 0. So we put that to a number line. So I'm going to quickly put that over here on the right and say we have 2 points to look at, really, is negative 7 and 1. And we want to test out the areas here, here, and here. Because we know if we plug these in, we're going to get zeros which don't count for this. Because we're looking less than or greater than 0. So we're going to test out the areas around it. So if I plugged in negative 8, I'm going to do some quick math here and say that if you plug in negative 8, you're going to get negative 8 minus 1. You're going to get a negative number. If you have negative 8 plus 7, you're also going to get a negative number. Together they equal a positive number. So that's fine and dandy, but we want to know where it is negative. So this does not constitute part of our region for our x value. Alright, so let's keep going. I'm going to do this one underneath, and I'm going to test out. I should put negative 8 as a test here. I'm going to use 0 now. 0 is going to be my next test, and if I plug in 0 here, what I'm going to get is a negative, because 0 minus 1, and then you're going to get a positive 0 plus 7, so it's going to become overall negative, which this is a good region so far. In between the numbers works. So let's keep going. Now, you may have already said, oh, well, I know it's a quadratic, and obviously it can only be this part of the region now, but just for, testing it out, we're going to put 2 in here. 2 is going to be 2 minus 1. That's going to be positive. And then 2 plus 7 is going to be positive, so we're going to be getting a positive number. Undo that. There we go. And so the only region that really exists for us is going to be this region here. So we get a negative 7 to 1 region. Remember that we have an exclusive region here because it is not including negative 7 or 1 because it is less than. So let me box that answer, and that is your result for question 1. Okay, let's try another one. Alright, now solving for this inequality, we have here a numerator and a denominator. Now, I'm going to give you some strategies in just a moment, but let's see what you can do and how you would make your first attempt at this, and I will continue in just a moment. Alright, to get started, one of the things you want to look at is basically here, this is a mess. So what you want to do immediately is say that you're going to end up factoring that out. So I'm going to rewrite this and say 2x minus 5 cubed is equal to, now I factor this out, and that's going to be 7 and 4, and the 7 is going to have the negative, and this is going to have the positive here, and this is all greater than or equal to 0. note what this greater than or equal to 0 means, that it wants to be 0, but it's also positive region, so that's going to be really helpful. And actually, one of the things I would like to just note to you is that when we have this here and this, notice they're all multiplying or dividing each other, and it actually gives us a very easy way to test all these systems. And that we want to be able to also just simply plug into this, and this, these values to see what 0 could be, because if any one of them is 0, we have problems. So let's find our zeros. So the first part is, I'm going to say 2x minus 5 is going to be equal to 0, solve for x, and that's going to be equal 5 halves. Okay, and then x is going to be equal to 7, and x is going to be equal to negative 4, and those easy ones here and here. So we have 1, 2, 3 values now to put into our number line. Let me put it over here. So we're going to have negative 4, and we're going to have 5 halves, and we're going to have 7. Okay? And what you want to do is just really easily try to test these as easy as you can, I should say, that when these are multiplying each other, we just look at when they're going to be negative, that'll be a positive, and if this was a positive here, then that would be positive. So we're just testing all that out now. So negative 4, I'm going to try a point of negative 5, okay, and just see what that yields out. Here, I shouldn't write like that. I should just put negative 5 and just say we're going to get, in the numerator, we're going to have 2 times negative 5, that's negative 10, minus 5, that's a bigger negative, cubed is also going to be still negative. So we're going to have negative 5 minus 7, we're going to have another negative, and negative 5 plus 4, you're going to still have another negative. So the denominator becomes positive, negative over positive, though, makes this region negative. Alright, next region. I'm going to pick a very easy one. I love picking 0 when I can. It's just such an easy one to work with. So let's use 0. You are going to have the numerator, by the way, it's not going to be 0. You're going to have 2 times 0. Yes, that becomes 0, but it's still negative 5 cubed, so it's going to be negative. And then we have the bottom. We're going to have a negative number here for 0 minus 7 and a positive number here for 0 plus 4. So we're going to get, in this region, a negative region. Okay, let's keep going. So now I'm going to move on to 5 halves. I'm going to pick a better point. I'm going to pick 2 here, nice number. And I'm going to do it in this region. 2 times 2, it's going to be 4 minus 5. It's still going to be a negative number in the numerator. So 2 minus 7, that's going to be a negative number there. And then 2 plus 4, that's going to be a positive number there. So if we're going to get a positive number there because it's negative over a negative in the end, okay, that means this region doesn't work either. Now, I want to mention, I just didn't notice my error. Just seeing this to the left is that we actually have a negative over a negative here, because it's the negative times a positive. So you're actually going to get this cancel out to be positive in the end, so this becomes positive. All right? So I just want to rectify that just because I paid attention to that just now. Okay, so we're going to try now a different point over here. Let's pick 8. Just pick an easy number. You can pick any number in this region, but I pick 8. So 2 times 8, that's 16. 16 minus 5 is 11. And you're going to have 11 cubed. That's a positive number in the numerator, finally. And then you're going to have now 8 minus 7. That's going to give you 1. So that's going to be a positive in the denominator. And you're going to have 8 plus 4. That's going to be also positive. So we all have this region here. So I'm going to circle it. This is a positive region. Between those points, we want to be inclusive because those are zeros. And here as well, this region. Now, I would say you would normally want to be inclusive, but so I misspoke there, is that, remember, these are zeros, right? Well, we can't exactly forget this here, this denominator. Even though these are zeros, note that these zeros would actually cause you dividing by 0. So this is a boundary issue. So when we actually type in or write out our answer, x, okay, can be from, in this case, negative 4. We have parentheses for that. It can't exactly be it for 5 halves, but it can be 5 halves, so we're including that. And we want to also say or is going to be this symbol. Oh, and my mistake. That's the other symbol for OR. And we're going to do a U here. And we're going to say that it is from 7. We want to be not including 7 in this to infinity. There. And there we go. That is our answer for this one. All right. Let's do one more type of problem. So in this case, we're actually going to be giving an equation for the following graph, and this is the curve we're following, like so. So I want you to give your best attempt for this. Alright, so let's get started. The first thing you might notice is that there's an end behavior going on here and here, and what does that tell us? That this is downwards and this is up? Well, it gives us the idea that this is an odd function. And not only is it an odd function, but it's also with a leading coefficient that is positive. So those are two main hints here. But the thing is, would I simply say this is a cubic? And I would say no. It's definitely not a cubic because we have a few things going on here. A cubic would look something like, I'll draw this in blue, simply going like that. Right? In this case, this would not be simply a cubic. We can't say that point yet. What we're going to look at are these intersections with the x-axis. Those are hugely telling for what we're going to be determining as our function. So the next bit for us is going to be really looking at, based on these clues, that we want to look at these zeros. These zeros are going to be really telling for our function. So we can just start it out by writing f of x is equal to where our zeros are going to be. Well, let's look at the first one. I like this one a lot because it's really easy to do. Since we have a 0 at 0, we can just simply say, well, when x is there, being 0. But we have to say what type of degree. Is it going to be even or is it going to be odd? And that's based on the multiplicity here. And I see that we have a multiplicity that is even here because it's boing, bouncing off of the x-axis. So I'm just going to say that this is x squared. Now you can edit your degrees later, but I'm leaning towards x squared. So let's keep going, and I'm going to go to the next one. Notice it is slicing through 1. So that means that when we have a 0 there, well, the only way to have a 0 there is x minus 1. So we have that as a degree of, let's just say 1 here. I'm going to pick the easiest ones. You could have higher degrees, obviously, but I'm just picking 1 because it's just an easy one to work with. So let's keep going, and I notice as I'm going down, and I boing off the x-axis again, and I get 3 here. Well, for 3, that's also going to be x minus 3, but in this case, it's bouncing off the x-axis, so that means it must be an even degree here. So you might say, oh, aren't we done? Well, we just have to double check one last thing and see if these here, this whole thing here, checks with the hint here and the hint here. So let's check. If I take the total for my degrees, I'm going to get 2 plus 1 plus 2. I get 5. That's going to be a quintic function, which means that it is odd, so that checks out. And the last bit is to check to see your leading coefficient. Is it going to be positive? Well, x is positive here, x is positive here, x is positive here. That's going to be x squared multiplied by x to the first multiplied by x squared. That's going to be a leading coefficient that is positive. So actually this one is a fairly nice one. I actually really like these types where you can just quickly suggest what function this could be. Now, are there many answers? Yes. There could easily be more answers of higher degrees here that still fit these clues. Based on this given information alone, these zeros, end behavior, we have this function. So, I'm glad you could join me, and I hope you enjoyed the lesson. See you all next time.